Question 1. In the context of system component failure in low-pressure chillers, technician Maria is dispatched to troubleshoot a centrifugal chiller experiencing frequent high-pressure cutouts. She finds the purge unit has been running excessively and records show frequent venting over the past 2 months. What should Maria conclude is the most likely issue? A. The purge unit has a faulty timer causing overcycling. B. Air and non-condensables are entering the system due to a leak. C. The condensed tubes are fouled, reducing heat transfer. D. The high-pressure switch is defective and needs replaced. Answer. Correct answer. B. A. And non-condensables are entering the system due to a leak. Explanation. Frequent operation of the purge unit combined with excessive venting indicates air infiltration. Symptom of leaks in low-pressure systems operating under vacuum. Non-condensables like air increase head pressure, triggering high-pressure cutouts. Section 608 mandates leak repair if leak rates exceed thresholds, 10% for comfort cooling, % for commercial industrial process. Purge units should not be compensating continuously. This is red flag for system leakage, not control failure. EPA 40 CFR Part 82 Subpart F. Question 2. Based on the information in a routine inspection, technician Derek observes that a low-pressure system is being pressurized to 25 sig with nitrogen to perform a leak test. What immediate action should Derek take? A. Proceed with the leak check to identify micro-leaks. B. Vent refrigerant to reduce internal pressure to below 15 sig. C. Notify the supervisor that this pressure exceeds safe limits. D. Introduce a trace amount of refrigerant to improve accuracy. Answer. Correct answer. C. Notify the supervisor that this pressure exceeds safe limits. Explanation. Low-pressure systems like those use ASHE 123 or CFC 11 should not be pressurized above 10 sig when leak testing with nitrogen and trace refrigerant. Pressures exceeding 10 sig risk rupturing system components such as rupture discs, which are designed to burst at 15 sig per ASHRE 15 and EPA 40 CFR Part 82. Overpressurization is not only a safety hazard but also a violation of EPA safety practices for low-pressure appliances. Question 3. From the perspective of refrigerant recovery, technician Simone is tasked with recovering CFC 11 from a chiller undergoing retrofit. The system is idle, and all refrigerant has migrated to the evaporator. Which method will ensure complete recovery? A. Use the push-pull method to quickly remove the refrigerant. B. Lower system pressure by chilling the evaporator with ice. C. Heat the evaporator while applying a vacuum to draw out vapor. D. Open the rupture disc to release the last remaining refrigerant. Answer. Correct answer. C. Heat the evaporator while applying a vacuum to draw out vapor. Explanation. For low-pressure systems, refrigerant tends to collect in the evaporator when idle. To recover vapor, EPA guidelines 40 CFR 82.156 recommend raising evaporator temperature, typically using hot water or heat blankets while evacuating with recovery equipment. This boosts vapor pressure and improves recovery efficiency. Push-pull isn't effective with low-pressure refrigerants due to their low boiling points, and rupture discs must never be used to vent refrigerant. Question 4. The fundamental question is, what is the primary purpose of a purge unit on a low-pressure centrifugal chiller? A. Add refrigerant during normal operation. B. Maintain refrigerant pressure below atmospheric pressure. C. Remove non-condensables from the system. D. Maintain system temperature during standby. Answer. Correct answer. C. Remove non-condensables from the system. Explanation. Purge units are essential for maintaining efficiency and safety in low-pressure systems by removing non-condensables, e.g. air and moisture, that infiltrate due to vacuum operation. These substances increase head pressure, reduce efficiency, and accelerate corrosion. According to EPA regulations, excessive purging indicates a leak and must be investigated. 4 CRS 156I. Their purpose is not to regulate refrigerant pressure, temperature, or charging processes. Question 5. When evaluating the merits of various leak detection methods, technician Farah uses ultrasonic leak detectors on a low-pressure chiller operating under vacuum. She reports no audible leak signals. What limitation is affecting her results? A. Ultrasonic detectors can't pick up refrigerant sounds below 0°. B. Leak detection under vacuum renders ultrasonic tools ineffective. C. Ultrasonic detectors are not approved under EPA 608. D. The chiller is too noisy for detection to be effective. Answer. Correct answer. B. Leak detection under vacuum renders ultrasonic tools ineffective. Explanation. Ultrasonic detectors rely on high-frequency sounds emitted by pressurized gas escaping from a leak. Under vacuum, there is no outward movement of gas, making this method ineffective. For low-pressure appliances, EPA recommends pressurizing with nitrogen equals 10 sig and trace of refrigerant to detect leaks using bubble or electronic methods. 40 CFR Part 82, Appendix B. This ensures compliance while accommodating vacuum limitations. Question 6. In what ways can the rupture disk on a low-pressure system be compromised, leading to potential EPA violations? A. The disk is often reused after it ruptures. B. Overcharging refrigerant without venting causes rupture. C. Improper leak testing pressures may cause the disk to burst. D. The disk fails when too little refrigerant is in the system. Answer. Correct answer. C. Improper leak testing pressures may cause the disk to burst. Explanation. Rupture disks are a critical safety component designed to release at 15 sig. Leak testing above recommended 10 sig using nitrogen can accidentally cause these disks to rupture, resulting in the illegal release of refrigerant. EPA 40 CRS.156. Disks must be replaced, not reused, and bursting from overpressure during testing is preventable violation under Section 608. Overcharging generally doesn't affect rupture disks in low-pressure systems. Question 7. During the process of evacuating a low-pressure chiller after a major repair, technician Charles reaches 20-inch 8G vacuum but is unsure if he can proceed with charging. What should he verify first? A. That the system holds a vacuum for 1 hour. B. That pressure rises are due only to residual refrigerant. C. That the system reaches at least 25-inch 8G before stopping. D. That the pressure remains steady for 24 hours. Answer. Correct answer. A. That the system holds a vacuum for 1 hour. Explanation. EPA requires that after evacuation, the system must demonstrate vacuum integrity. For systems containing over 50 pounds refrigerant, a standing vacuum test holding 25 mm Hg or deeper for 1 hour is required to ensure no leaks or moisture remain. 40 CFR 82.156. A rising vacuum suggests a leak. Outgassing from system components. Pressures alone are not sufficient. Holding the vacuum confirms system integrity. Question 8. To illustrate this point, technician Angelo is reviewing a service record indicating that a comfort cooling system using 65 ounces of CFC11 lost 9 pounds in a calendar year. What is the appropriate regulatory action based on EPA 608 type Roma rules? A. No repair required since it's under 15% threshold. B. Mandatory retrofit or retirement must be initiated. C. System must be repaired within 30 days. D. System must be removed from service. Answer. Correct answer. C. System must be repaired within 30 days. Explanation. Loss of 9 pounds out of 65 pounds represents a leak rate of 13.8%, exceeding the 10% threshold for comfort cooling systems per EPA regulations. Fortsefer SOI 157. Once the leak rate surpasses the threshold, repairs must be completed within 30 days unless granted an extension or retrofit plan. Retirement required only if repairs are not feasible or repeatedly unsuccessful. Question 9. To careful analysis of recovery techniques, technician Raj uses a water-cooled recovery unit for a chiller repair. What benefit does this method offer during vapor recovery from a low-pressure system? A. It allows recovery without heating the chiller. B. It increases the recovery tank pressure for faster filling. C. It keeps the chiller temperature constant. D. It lowers the system pressure to improve vapor flow. Answer. Correct answer. D. It lowers the system pressure to improve vapor flow. Explanation. Water-cooled recovery units provide superior heat rejection compared to air-cooled ones, keeping condenser temperatures low, thereby reducing system pressure and improving vapor recovery rates. This is critical in low-pressure systems where refrigerant boils at low temperatures. It complies with EPA Recovery Performance Standards 40 CFR 82.150 and enhances recovery without excessive chiller heating, which risks damaging components. Question 10. In light of recent developments, Technician Omar is training a new employee and demonstrates that refrigerant removed from a low-pressure system is sent to a reclaimer, not reused on site. Why is this distinction important under EPA regulations? A. It allows the technician to avoid cylinder labeling. B. It ensures the refrigerant meets purity standards before reuse. C. It prevents technician liability for future leaks. D. It avoids needing to record refrigerant weight. Answer. Correct answer. B. It ensures that refrigerant meets purity standards before reuse. Explanation. According to Section 608, used refrigerant must be reclaimed to RA 700 standards before reuse in another system 40 CR S.154. Recycling is only allowed if reused in the same owner's equipment. Reclamation ensures removal of contaminants and oil to maintain system integrity, purity against moisture, acid formation, and equipment damage, helping enforce EPA's goal of minimizing emissions and maintaining operational safety. Question 11. By comparing the functionality of system safeguards, Technician Elise notices that the ruptured disc on a low-pressure chiller has ruptured. The system had recently been leak tested using nitrogen at 12 sig. What is the most likely explanation for this failure? A. The system was overcharged during operation. B. The ruptured disc was incorrectly installed. C. Excessive nitrogen pressure caused overpressurization. D. The disc was aged and due for replacement. Answer. Correct answer. C. Excessive nitrogen pressure caused overpressurization. Explanation. EPA prohibits pressurizing low-pressure systems above 10 sig during leak testing. Nitrogen at 12 sig can activate the ruptured disc, typically designed to burst at 15 sig, 40 CFR S.156. This causes illegal refrigerant release and is violation of EPA guidelines. Overcharging is irrelevant during testing, and aging ruptured discs do not rupture from pressure alone if within safety limits. Question 12. Under the assumption that proper charging procedures must be followed, Technician Victor prepares to charge a low CFSO11 chiller. Which step must be taken to prevent freezing of water tubes during the charging process? A. Open the purge unit during charging. B. Start with liquid refrigerant at high pressure. C. Charge with vapor until pressure rises above 36 stick saturation. D. Drain water from the tubes before charging. Answer. Correct answer. C. Charge with vapor until pressure rises above 36 stick saturation. Explanation. Charging low-pressure systems initially with vapor prevents refrigerant from flashing and causing the water in tubes to freeze. Once system pressure is above the freezing point of water, 36 stick saturation equals 16. ECUM for EFC 11. Liquid charging can begin safely. This practice is consistent with EPA recommendations and RE guidelines. Purge units are not used during charging, and draining water is not standard practice. Question 13. The growing trend in leak prevention highlights Technician Melanie's concern that low-pressure appliance loses refrigerant yearly despite annual servicing. What factor would most contribute to ongoing leakage in this system? A. Improper filter dryer selection. B. Frequent power outages. C. Operating under deep vacuum. D. Using reclaimed refrigerant. Answer. Correct answer. C. Operating under deep vacuum. Explanation. Low-pressure systems operate under vacuum during normal conditions, making them vulnerable to air and moisture infiltration. Gasket deterioration, vibration, or improper evacuation increase leak potential. Even minor vacuum leaks pull in non-condensables. EPA 608 guidelines stress that deep vacuums require extra diligence for leak detection and prevention. Reclaimed refrigerant doesn't inherently cause leaks, and power outages only affect performance, not leakage. Question 14. The core principles of record-keeping are tested when Technician Aisha disposes of a 60 EFE11 system. What documentation must she retain to comply with EPA rules? A. The name of the technician who removed the refrigerant. B. A receipt from the EPA for system retirement. C. An invoice showing new system installation. D. A record of the final leak rate at retirement. Answer. Correct answer. A. The name of the technician who removed the refrigerant. Explanation. EPA 40 CFR S.166 requires owner-operators to maintain documentation for refrigerant recovery or evacuation, including technician identity, recovery equipment used, and amount recovered before appliance disposal. This ensures proper recovery and supports enforcement of the refrigerant management rule. EPA does not issue receipts for system retirement. Leak rates are not required for retirement documentation. Question 15. Throughout the course of an inspection, technician Lewis uses a deep vacuum gauge with a micron scale and observes pressure stabilization at 1000 microns. What does this indicate about the system's dehydration status? A. The system is fully dehydrated and ready to charge. B. Moisture still exists and further evacuation is needed. C. Non-condensables have been completely removed. D. The system has refrigerant leak. Answer. Correct answer. B. Moisture still exists and further evacuation is needed. Explanation. EPA guidelines recommend pulling vacuums below 500 microns to effectively remove moisture from the system. Stabilization at 1000 microns means moisture is still present and dehydration is incomplete. Pressure should fall and hold well below 500 microns to ensure no moisture remains. Holding pressure indicates leak-free conditions. The moisture level is still unacceptable for charging. Question 16. In response to a service call, technician Jamal finds that the centrifugal chiller EPA 123 has failed its annual leak test and exceeds the threshold rate. What is the EPA mandated next step if repairs cannot be made within 30 days? A. Notify EPA of the delay and resume operations. B. Replace the purge unit to minimize emissions. C. Develop and document a retrofit or retirement plan. D. Vent the system and prepare for full decommissioning. Answer. Correct answer. C. Develop and document a retrofit or retirement plan. Explanation. Under 40 CFRS Point 157 F, if leak rate thresholds are exceeded and repairs cannot be completed within 30 days, the owner must either retrofit or retire the appliance within 12 months. The plan must be documented within 30 days of discovering the leak and made available for inspection. Venting refrigerant is illegal. Purge unit replacement does not fulfill regulatory obligations. Question 17. Considering the evidence from a refrigerant analysis report, technician Nolan rejects a recovery cylinder due to excessive acidity and moisture. Why is it crucial to follow this protocol before reintroducing refrigerant into a low-pressure system? A. It prevents cylinder corrosion during transport. B. It maintains compliance with shipping labels. C. It ensures system oils remain compatible. D. It protects system components from corrosion and sludge. Answer. Correct answer. D. It protects system components from corrosion and sludge. Explanation. Moisture and acid in recovered refrigerant can cause internal corrosion, form sludge, and destroy motor windings and bearings. EPA mandates that refrigerant reused in other systems must be reclaimed to RE700 standards. 40 CFR S.154G. Technicians must test for purity before reuse. Introducing contaminated refrigerant violates standards and compromises system longevity. Compliance is unrelated to refrigerant purity for system re-entry. Question 18. The effectiveness of different recovery strategies becomes evident when technician Sarah uses a system-dependent recovery method on a 12 lb appliance with EPA 123. Under what condition is this method allowed? A. The appliance is connected to a purge unit. B. The equipment is approved by the EPA. C. The system contains less than 15 pounds of refrigerant. D. The appliance is located outdoors. Answer. Correct answer. C. The system contains less than 15 pounds of refrigerant. Explanation. System-dependent recovery is only permitted for appliances with less than 15 pounds of refrigerant under EPA 40 CFR Point 156A1. This method uses the appliance's compressor or internal pressure to push refrigerant into recovery container. Appliances with greater refrigerant charges require self-contained recovery equipment. Location and purge units do not affect recovery method eligibility. Question 19. The Clean Air Act requires technician Dean to verify recovery machine efficiency. What is the EPA standard for recovering refrigerant from A low-pressure appliance before disposal. A. 10 inches of mercury vacuum. B. 15 inches of mercury vacuum. C. 25 inches of mercury vacuum. D. 0 sig with full liquid removal. Answer. Correct answer, C. 25 inches of mercury vacuum. Explanation. EPA recovery requirements for low-pressure systems mandate achieving a vacuum of 25 Hg or more before disposal, 40 CRS.156. This ensures that nearly all refrigerant is recovered. Technicians must use certified recovery equipment capable of reaching this vacuum. Simply reaching 0 sig or removing liquid is insufficient. 10 or 15 Hg would leave significant refrigerant behind. Question 20. While examining a low-pressure system's operational log, technician Prayer notes that the purge unit runs longer each day despite no recent servicing. What inference can she reasonably draw from this behavior? A. The system efficiency is improving. B. There is a rise in internal refrigerant temperature. C. Air is leaking into the system, increasing non-condensables. D. The refrigerant charge is too high. Answer. Correct answer, C. Air is leaking into the system, increasing non-condensables. Explanation. Prolonged purge unit operation suggests increasing levels of non-condensables, typically due to air infiltration caused by vacuum leaks. This raises head pressure and reduces efficiency. According to EPA 608 rules, frequent purging is a leak indicator and triggers mandatory repair if thresholds are exceeded. 40 CFR S.157. Increased refrigerant temperature or overcharging does not account for frequent purging behavior. Question 21. Taking into account system evacuation requirements, technician Marcus finishes repairing a 90 FE11 chiller. Before recharging, what vacuum level must he achieve to meet EPA regulations for post-repair evacuation? A. 10 inches of 8G vacuum. B. 15 inches of 8G vacuum. C. 25 mm Hg absolute. D. 25 inches of 8G vacuum. Answer. Correct answer, C. 25 mm Hg absolute. Explanation. After a major repair on a low-pressure appliance, 50 pounds, EPA mandates the system be evacuated to 25 mm Hg absolute, equal to 29.9 E before recharging 40 CRS.156. This deep vacuum removes air, moisture, and non-condensables. Using inches of Hg is outdated for this purpose. EPA specifically uses Hg absolute for clarity. Anything less fails to meet EPA recovery requirements. Question 22. During the process of cylinder handling, technician Omar stores recovered CFC11 refrigerant in a .39 cylinder for transport. Which action must he ensure before shipping the cylinder? A. Fill the cylinder completely to avoid gas expansion. B. Vent the cylinder to relieve pressure. C. Properly label the cylinder with refrigerant type and safety classification. D. Cover the cylinder in black plastic to protect from sunlight. Answer. Correct answer, C. Properly label the cylinder with refrigerant type and safety classification. Explanation. .39 cylinders must be labeled with the refrigerant type, chemical name, and hazard class per EPA and regulations. 49 CFR Parts 171, 180 and 4 CR S.154. Labeling ensures safety during handling, shipping, and storage. Overfilling or venting is illegal, and black plastic coverings have no regulatory requirement. Labels prevent misidentification and regulatory violations. Question 23. In contrast to typical split systems, technician Leslie is working on a low-pressure chiller. She wants to verify a suspected leak after shutdown. What method is most appropriate for leak testing in this situation? A. Open air sniff test. B. Pressurize with nitrogen and a trace of refrigerant. C. Spray soap solution near the expansion valve. D. Run the system and check for bubbles or connections. Answer. Correct answer, B. Pressurize with nitrogen and a trace of refrigerant. Explanation. Low-pressure systems operate in vacuum, so leak detection requires pressurizing to a maximum of 10 sig with dry nitrogen and a trace of refrigerant to prevent system contamination and meet EPA 608 requirements, 40 CFR S.156. This allows for electronic or bubble detection without risking overpressure. Open-air sniff tests and spraying soap near components without pressure are unreliable and non-compliant. Question 24. With respect to refrigerant characteristics, which of the following statements accurately describes low-pressure refrigerants like HEFE 123 and CFC 11? A. They operate above atmospheric pressure in the evaporator. B. They boil at very low ambient temperatures. C. They require very high system pressures to condense. D. They create a vacuum in the system during normal operation. Answer. Correct answer. D. They create a vacuum in the system during normal operation. Explanation. Low-pressure refrigerants boil at temperatures near or above room temperature, meaning their systems operate in a vacuum subatmospheric pressure. This increases the risk of air moisture intrusion. EPA recovery protocols and system design standards are tailored to this characteristic. 40 CRS.156 and ASHRAE Guideline 3. These systems do not require high condensing pressures, unlike high-pressure refrigerants. Question 25. During a training session, technician Fiona teaches that after recovering refrigerant, certain steps must be taken before system disposal. What action is legally required under EPA 608? A. Record refrigerant type on service tags. B. Remove all oil and refrigerant to required levels. C. Label the compressor with technician initials. D. Cap all service ports with plugs. Answer. Correct answer. B. Remove all oil and refrigerant to required levels. Explanation. Before disposal, EPA requires all refrigerant to be recovered to the mandated vacuum level 25. E for low-pressure systems and recommends removing oil to prevent environmental harm 40 CRS 156F. There's no federal requirement to cap ports or label compressors with initials, though they may be good practice. Recording refrigerant type is only relevant for transport or documentation, not disposal. Question 26. A demonstrated bio-review of refrigerant compatibility. Technician Donnell adds mineral oil to a 123 system without checking the oil label. What could be the consequence of mixing incompatible oils with HFC 123? A. It will increase recovery efficiency. B. It may cause acid formation and compressor damage. C. It will improve system cooling performance. D. It will neutralize any residual contaminants. Answer. Correct answer. B. It may cause acid formation and compressor damage. Explanation. Mixing incompatible oils can result in phase separation, sludge formation, or acid buildup, especially when exposed to moisture or heat. GFC 123 is often used with alkyl benzene or polyester oils, not mineral oil. Acid formation degrades windings, bearings, and internal parts. EPA does not regulate oil type. The proper oil usage ensures system reliability and prevents breakdowns. ASHRAE Standard 1534. Question 27. To determine whether a low-pressure chiller leak requires EPA compliance action, technician Claire calculates a loss of 13 pounds from a 100 NAFE 123 system used for industrial process refrigeration. What is the leak rate, and is it over the EPA threshold? A. 13.1%. Over the 10% limit. B. 11.8% over the 10% limit. C. 10.4% under the 20% threshold. D. 11.0% under all thresholds. Answer. Correct answer. B. 11.8% over the 10% limit. Explanation. EPA leak rate equals pounds lost full charge x 100 equals 13,110 x 100 equals 11.8%. The threshold for industrial process refrigeration EPA is 30%, not 10%. However, the question asks for compliance action, and 11.8% is well below the EPA limit. Therefore, B is mathematically correct, but should not require action unless misinterpreted as comfort cooling system threshold 10%. So technically, this is trick to test understanding of thresholds. Question 20. The traditional approach to oil removal is examined as technician Jorge opens an oil drain port on a decommissioned centrifugal chiller. What precaution must he take regarding potential refrigerant release? A. Ensure oil is at room temperature before draining. B. Open the ruptured disc for better flow. C. Check for trapped refrigerant in the oil. D. Drain only after the system is fully charged. Answer. Correct answer. C. Check for trapped refrigerant in the oil. Explanation. Oil in low-pressure systems often contains trapped refrigerant, especially if the system has been idle. Draining it without venting can release refrigerant and violate EPA venting prohibition 40 CFR.154. Oil should be handled carefully, and technicians must assume refrigerant is present unless verified otherwise. Heating oil is unnecessary and dangerous if refrigerant is still mixed in. Question 29. A key distinction between vapor and liquid recovery in low-pressure systems is important when technician Anya is instructed to recover all refrigerant from an 811 chiller before dismantling. What recovery method must she complete last? A. Push-pull liquid recovery. B. Liquid removal from evaporator. C. Vapor recovery after heating. D. Purge recovery unit operation. Answer. Correct answer. C. Vapor recovery after heating. Explanation. After liquid refrigerant is removed, residual vapor remains and must be recovered. Heating the evaporator raises vapor pressure, enabling efficient recovery. EPA mandates that both liquid and vapor be recovered before system opening 40 CFRS.156. Vapor recovery is always the last step in full recovery. Push-pull is for high-pressure systems and not effective for low-pressure appliances. Question 30. The prevailing attitude toward refrigerant management has emphasized stricter tracking. When must a technician or facility owner submit reports to the EPA about refrigerant use or disposal? A. Whenever a technician replaces a compressor. B. When more than 5 pounds of refrigerant is handled. C. If requested during an EPA inspection or audit. D. After refrigerant is purchased from a supplier. Answer. Correct answer. C. If requested during an EPA inspection or audit. Explanation. EPA requires records to be maintained for 3 years but not regularly submitted unless specifically requested during an audit or enforcement inspection 40 CRS.166. Reports may include leak repair logs, recovery quantities, and maintenance dates. Submission is only mandatory in certain large-scale violation scenarios. High-quantity transfers, not routine component replacement or purchase.